Hello everyone and welcome back to Clear Creek Solutions hydrology education videos. And in today's video we're going to cover what is HSPF and what are some of the things involved with modeling with something like HSPF and how it is different than a lot of hydrology modeling methods or softwares that we see today. So that's what we're going to cover in this video. So HSPF stands for Hydrologic Simulation Program for TRAM. So that's the engine that it comes packaged in, and there's been a long process for HSPF to be developed and now used in certain modern software situations, and us at Clear Creek Solutions have learned to utilize HSPF and design in it. So we have covered the many different ways to model stormwater runoff in facilities. But however, many of these simplistic methods were created before computers and high-powered processing. So believe it or not, things like the rational method or the SCS runoff method, all of those things were created before we got high-power computers. And so I don't blame people for back then using these methods. We didn't have computers. We had to do the best we can with slide rule calculators and things like that to make things work. But now that we have advanced computers that can do enormous amounts of processing, even compared to something 30 years ago, our computers can do massive amounts of processing. It's time for us to leverage all that power when it comes to our stormwater design. We shouldn't be stuck in the past way of doing things, but really find a better way to simulate the hydrologic cycle. So this is the hydrologic cycle. Think about all the components that are contained in the hydrologic cycle, or also known as the water cycle. We have condensation, then we have precipitation, and then immediately we'll have some evaporation and transpiration. Snow melt is involved with this as well, creating lakes and then water now percolating into the soil, eventually creating groundwater flow that either heads to the ocean or heads even further into the reservoir, and then eventually evaporates again, and the entire process starts all over again. So there's a lot to this and a lot of factors and components involved. And so what we're saying here is simple methods, yes, may get you an estimate or may have a specific use, but really if we want to model the entire hydrologic cycle, get an entire picture of what's going on, we need something with some processing power that can account for all these different things that are part of this process. So let's try and understand this hydrologic cycle from a modeling perspective. So the hydrologic cycle includes many different components, and any hydrologic modeling software needs to be able to account for changes of the following things, I would say at a minimum. Something like rainfall intensity, soil saturation, and then the storage in that soil, the surface runoff that's created, and then the inner flow and groundwater movement, and then the eventual evaporation of that rainwater. All this needs to be accounted for when we're designing facilities. So what are some of the single event hydrology methods that are used today? Well, I talked about these, and these modeling methods are used in many jurisdictions across the country. We have the rational method, and that's a method utilizing equations such as Q equals CIA. We have plenty of videos on that method on our channel. And assuming dry soil conditions before rainfall, and it has a limited use for calculating runoff of a site. So that's would be the limited use of it. But there's a lot of assumptions that go into something like the rational method. Just like the SCS runoff method, which is an empirical relationship between retention and runoff of a rainfall event, it utilizes equations such as S equals 1000 divided by curve number minus 10. So single event hydrology methods can work in areas with long breaks between storm events that allow soil conditions to normalize and facilities to empty. Think of a desert, right? If it rains in a desert, it's likely that the soil conditions are going to be dry beforehand. You're going to get a pretty calculable amount of runoff from that soil, from that project area. And there's going to be a long period of rain or a long period of sunlight and evaporation to finally empty out and normalize those soil conditions. And then the process repeats. It's kind of easier to tell what kind of runoff you're going to get from that site, as opposed to areas with constant rainfall where the soil is constantly saturated or it's constantly changing. So what are some of the single event hydrology limitations? Well, first of all, it assumes that a specific storm return period produces the same return period flood. So e.g., a 2-year storm always produces a 2-year flood. It also assumes a representative storm of a standard shape and volume, aka a type 1A storm, to compute that runoff. They also include the assumption of a certain average soil moisture condition at the start of the rain event, which I talked about earlier. These single event methods, by their very nature, have no mechanism to simulate back-to-back storms, variable soil moisture conditions, or the effects of long-term infiltration and evapotranspiration. In the real world, a two-year runoff event is going to be much different than the 2-year storm, because the soil conditions are not going to be stable or completely dry at the beginning of the event. So what's the background of HSPF? Well, it was developed in the late 1960s and early 1970s from the Stanford watershed model. Improvements were made in the 1980s with enhanced algorithms, and HSPF was integrated into future software used by jurisdictions worldwide. And with hydrologic and water quality modeling capabilities, HSPF is very effective at modeling climates with constant rainfall and unique soil types and conditions. And engineers will get a better picture of how the hydrologic cycle functions on their project site, as opposed to using a single event method. So what is the modeling process in HSPF in short? Well, HSPF follows a very detailed and thorough process to conduct a hydrologic analysis. First, you need rainfall and evaporation data. You need to understand the soil parameters at play, the amount and acreage and land use of the soil parameters and possible facility information. And then you need to conduct the run to collect the results that you need. So because HSPF can utilize years of rainfall data, in-depth information such as flow duration and distributions can be calculated from the model run. So this is an example of wwhm 2012, which utilizes HSPF for its calculations. You can see here we're able to actually model a facility and determine the percent time exceeding of different flow values based on the 50+ years of rainfall data included in the software. So we're not modeling just one storm event and seeing how that affects a facility. We're actually modeling years of stormwater events, determining what kind of flows are created from our project site, how many times that has exceeded, and then now we can design mitigation facilities to meet a certain range of flows. If you want to know more about flow duration, we have videos on our channel discussing that aspect. This is what a UCI file looks like for processing HSPF. It's quite involved, technical, and detailed. It takes years to get good at processing and building out UCI files. That's why at Clear Creek Solutions, we've built software such as wwhm 2012, wwhm-swmm, etc., that can build these UCI files for you over a nice, comfortable interface that you saw on the previous screen here. Things like purlins, which are included in HSPF UCI files, are included in wwhm 2012, but are predetermined based on the jurisdiction the software is in, so the user doesn't have to tamper with these functions, but are very important when it comes to HSPF. You can just see the number of purlin values that are included here. So HSPF has been integrated into continuous simulation software such as wwhm 2012, wwhm-swmm, BAM 2023, and many others. And due to its complex use, these software packages have become effective applications of HSPF. And the model contains hundreds of process algorithms developed from theory, laboratory experiments, and empirical relations from instrumented watersheds. So Clear Creek Solutions provides a complete range of hydrologic and stormwater modeling and consulting services, and that includes HSPF and its applications, and being able to apply it to your jurisdiction to get a better idea and to build better software so that engineers are equipped with the best tools when it comes to building mitigation facilities. If you have any questions about HSPF, leave it in a comment down below, and we have plenty of other videos on our channel about HSPF that are more in depth. We thank you so much for watching. Anyways, we will see you guys next time.